Tech Aliens, my name is Navin Reddy and let's continue with this series on Python. In this video, we'll talk about one of the most interesting concepts, at least from my side, and the concept name is threads. Now, why do we need threads? Now, first of all, what is a thread? Now, basically, if you can imagine an application, let's say if you have MS Word, that one application will have certain subprocesses, right? So in MS Word, we can type a content, we can change the font of it, we can save that in some other formats. So MS Office provides you so many features. So we can break down one task into multiple processes, and then again, we can break down those processes into a thread. So you can imagine thread as a lightweight process. So when you break down the big task into small parts, each part will be called thread. So why do we need threads? To understand this, let's go with the concept of multitasking. So what is multitasking? So let's say if you have a CPU and if you have multiple tasks, let's say you want to type something on MS Word, you want to listen to a music on VLC player, or you want to also browse the internet on Chrome. So if you want to do multiple tasks at the same time, so our system, basically any OS nowadays, any modern OS, let's say Windows or Linux-based OS or Mac, it does support multitasking, which means at one point you can run multiple applications. If you have learned OS, we have this concept, right? You cannot actually run multiple tasks at the same time. So as your CPU, it will do time sharing. So every task will get some time. And we know that, right? That's how your system works. We cannot run multiple applications at the same time. But nowadays, we have a concept of multi-core CPUs, right? We don't have one core nowadays, we have multi-core CPU. Example, the machine which I'm using now, this is a quad-core CPU. In fact, the mobile phone which I'm using now, this is octa-core CPU, right? Which means I have multiple cores available to work with. And on this multiple core, we can run multiple applications. But how? Let's think about one application, let's say MS Word. Now, while you're working on MS Word, at the same time you're typing, at the same time there is a spell check, at the same time maybe you're trying to save the file. On the other hand, let's say if you're playing a game, in game itself, we have so many events happening at the same time, Let's say if you're driving a car, you're playing NFS, at the same time you are driving a car, and then we have opponents, then we have cops. So we have so many things happening at the same time. That means we have individual threads. So you are one thread, your enemy is one thread, the cops are one thread, and then all these threads are getting executed on different cores, right? Not on same core, maybe on the same core, but most of the time it is on different cores. So if you have octa-core CPU, you can use all the 8 cores. In fact, if the software which I'm using for exporting the videos needs a high processing power. So what happens is if you have octa-core CPU, I can actually use all the 8 cores of my CPU. That's the advantage of using multiple threads. Now, in fact, if you can just go to your task manager, we have this option of performance, and there you can check, how many cores you have. So in this machine, I have 4 cores. And look at the threads now. So in total, we have 1,902 threads. Again, the moment I open one application, it will open more threads. The moment I close the application, it will have less threads. Example, if I open Eclipse, you can see it will have its own threads, right? The moment I open Eclipse, it will increase the number of threads which are required for that. So every application will have multiple threads. Now, how can we understand that in a programming way? So let's try to build our own threads in this code. So let me open my PyCharm. So we have a fresh look here. We don't have anything there. What I will do is, let's say if I define multiple functions, okay, just to keep it simple, what I will do is I will get 2 classes. One is hello. We have a hello class, and I don't know why, but the moment I say multi-threading, this is my favorite example. And then we have hi. So we have 2 classes here. We have hello class and we have hi class. And in both the classes, we have the same code. Let's say we have a definition. So this class has a function called as run or method called as run. And in this run method, what I want to do is I want to print hello 5 times. So I will say for I in range, I will specify the range as 5, okay? And then I want to print hello 5 times, right? So I will say print hello, that's it. So it will print hello 5 times. The same thing I want in hi as well. So I will simply reuse my code. Instead of saying copy paste, we should say reuse. And here I will say hi. So we got 2 classes, hello and hi. In hello, we are printing hello 5 times. We are printing hi 5 times. Now if you want to execute these two methods, logically what you do is you create objects of it, right? That's what we should be doing. We can have any name here. We'll say t1 is equal to, again you can have any object name, doesn't matter. So I'm saying t1, and t1 is the object of hello and t2 is the object of hi, right? Again you can use any name. You can use obj1, obj2 or whatever you want. As of now I'm using t1 and t2. So t1 is the object of hello, t2 is the object of hi. Now once I got the object of hello and hi, I want to call these functions or methods, right? So you will say t1.run, that's how you do it, right? And you will say t2.run. Now before running this code, just analyze what it will print. Of course, right, it will print 5 times hello, it will print 5 times hi. That's the format. Why it will print hello first then hi? Because that's how you're calling it. So you're first calling t1.run, where t1 is the object of hello, then you're saying t2.run, then it will call the run method of hi, right? Let's run this code, let's see what happens. So if you can see the output, we got 5 times hello and we got 5 times hi, right? This is what we were expecting. So normally what happens is, since you're calling run of hello first, it is printing hello 5 times, then you're calling run of hi, it is printing hi 5 times. And that's how the sequence goes, right? It always print hello and hi in that sequence. So let's imagine each run takes some time, okay? Of course, right, to print hello and hi takes some time, right? So let's say to print all hellos it takes 5 seconds, and to print all highs it takes 5 seconds, which means in total it will take 10 seconds. And we know that it is using only one core. So even if this machine has 4-core CPU, right, it is still using one core. I want to execute the run of hello and execute the run of hi simultaneously. Is it possible? Can I execute 2 functions at the same time on different cores? Or maybe on the same code but then simultaneously? Is it possible? Let's try. Now the moment you say you want to execute them parallelly, this is what you do. By default, every execution has one thread. So even if you are not creating a thread by yourself, you do have one thread, and that thread is known as a main thread. Okay, so this execution is done by a main thread. Okay, but I don't want to work with main thread. Of course, we have that, but I want to print hello and hi, but then with the help of 2 different threads. How will I create 2 different threads? It's very easy actually. So there's one way to have features is hello has to be a subclass of thread. It's very easy, right? So if you simply make hello as subclass of thread class, your job is done. Same goes with hi. Instead of normal class, we are making them thread, because now they can run individually on different cores. Oh, but we are getting error. Now when you want to use thread, you need to import a package, right? And that package is threading. So you have to say from threading import star. So you're basically importing everything from threading package or threading module. And now you can see we got 2 threads. We got thread and we got thread. Now once you have made them as thread, you will simply have to run them. It's so simple. Okay, before running this, what we are expecting is, so you can see the diagram here. So we have a main thread by default, right? And main thread will execute all the statements. The moment you say run and run here, it should create 2 different threads, which is, let's say t1 and t2. And t1 will print hello 5 times and t2 will print hi 5 times. And it should be happening simultaneously, right? So it should get the output as hello, hi, hello, hi. But let's run this code and let's see what happens. Oh, that's weird. We are getting same output. They are not running in parallel. What's wrong? See, the moment you say you want to create 2 different threads, this is not happening here. Even if you make your class as thread, we are not creating 2 different threads there. If you want to create a 2 different thread, instead of calling a run method, you need to call a start method. And that's weird, right? We are defining the method name as run, and then we are calling start. So behind the scene, what is happening is, when you say t1.start, internally it will call run. And the reason why we went for this method name as run is because inside thread class, we do have a method called run. So if you can see inside, I'm inside thread class now, and you can see we have a run method there. So it's an inbuilt method actually, and that's why we went for run. And if you're going for any other method, it will not work. So you have to make sure that instead of calling run, you have to say start, so that it will execute 2 different threads. Now let's try. So let's run this code and let's see what happens. Oh, we are still getting the same output. We are getting the same output. What is happening is, yes, these 2 threads are running simultaneously. Let me prove my point. What I will do is stop printing them 5 times to print them 500 times. Let's see what happens now. Let's run this code and you can see, oh, something happened here. If I go up, you can see that, we have so many highs. I'm going up, okay? So you can see we have alternate hi and hello. So you can see we got hello, hello, hello. And then suddenly we got 3 highs, and then we got hello again. And then we got highs, and then we got hello. So something is happening in parallel. right? But not exactly the way we want it. We want it to have one hi and then one hello alternate case. So that means it is happening in parallel, but then your system is so fast. This system is so fast that it is executing them at the same point, right? So there's a collision. Plus, in your system, we have a concept of schedulers, which will give you a specific time to execute. And we are expecting it will print only one hello in that particular time, but it is so smart, it is executing 10 times in that gap. It is printing 50 times in that gap. So to increase the gap, what I will do? Since it is going very fast, I will make it sleep. I will make it slow down. The way you do that is by importing a package. So you will use from time and you will import special method called sleep. So what you will do here is, so after printing hello, every time it prints hello, I will say, hey, sleep for, let's say, 1 second. So before printing the next execution, go for a sleep of 1 second. So now what will happen is, when hello gets printed, it will wait for 1 second, and by the time you can print hi once. So it will go alternate now. Let's see what happens. Let's run this code, and you can see it's going alternate way. You can see that we are getting hello, hi, hello, hi, hello, hi. So it's working, So both the functions or both the methods are running in parallel now. This is what we wanted, right? So that's great. It is working finally. If I scroll up, I hope everything is going good. Yeah, it's going good. So both the methods are running in parallel. So yes, we have 2 threads. Now you might be thinking why you have to put sleep there. Because normally when you create methods, normally when in big application, one method execution does take time. Okay, here we are just printing hello. That's not what we do in the industry, right? So normally we make big methods, and those methods will take some time to execute. And that's why I'm putting sleep there, because I'm assuming that we will be writing some big code to do that. I will just run this code once more and let's see if it is going good. Just a recheck if everything is going good. Yeah, it's going good. Oh, something went wrong. Can you see that? Something went wrong. We are getting hi, hello. Now what is happening here? Now this is called as collisions. Maybe it is happening that 2 threads are coming at the same time to the CPU. Okay, so because see, we are assuming that they will run in parallel, but suddenly they are going to the CPU at the same time after sleeping. So once they wake up, they are going to CPU at the same time. What I want to do is, so when we say start, t1.start and t2.start, I want to have a gap between them two. So I will put a gap of, let's say, 0.2 seconds. So let me put a gap of 0.2 seconds so that they will not go into collision. And now you can see, since there's a gap between these two, they will not collide now, hopefully. And yeah, it's working. There's nothing wrong. Yeah, it's working. This is how you can, unsync them, because initially they were sync and that's why they were colliding, but now they will not. Perfect. Okay, this is how you do it, right? This is how you make it work. So what is happening now is the moment you say T1 and T2 object, you got 2 different threads, but still they are into main thread, okay? So they are not separating. The moment you say start, it creates a new thread, okay? So in total, we will be getting 3 threads after this. So 3 threads, the main thread, T1 thread and T2 thread. Okay, so let's say I want to print something here. I want to print by. Now, what do you think? Where you will print this by? After printing all hi and hello, it will print by. In fact, let me just reduce the number of hi, hello here. Let me just go back to 8 because at least we can see what is happening. So what do you think? Or maybe 5 is better, right? Let's go for 5. So what do you think now? Will it print by at the end after hi, hello, or maybe somewhere in between? Let's run this code. So take your time, think about it, pause the video, think about it, comment if you want. And let's run this code. Oh, can you see that we got by in between? That's weird. Before printing hi and hello, how can you print by? The problem is, who is responsible to execute this by? Is it T1 thread or T2 thread? So who is responsible here is our main thread. So after starting T1 and T2, so T1 is busy printing hello, T2 is printing hi, main is doing nothing, right? And that's why main says, hey, my job is done, let me print by. We don't want that. We want to print by at the end. So we have to ask main thread, hey main thread, wait for T1 and T2 to join. How can you ask that? So you have to say, hey main thread, let T1 join and T2 also join. So please continue only after they are joining. So when you say T1.join and T2.join, at this point you are asking your main thread, because all these statements will be executed by the main thread. So at this point, main thread will say, okay, you are asking me to wait for T1, I will do that. So at this point, main is waiting for T1. Now once T1 comes back, it is waiting for T2. Once T1, T2 comes back, it will print by. Let's verify. You got hello, hi, hello, hi, hello, hi. At the end, you will get by. That's the power of join. So that's the basic of threads, okay? So the advantage of threads is you can use multiple cores and you can execute things simultaneously. In fact, I will try to make one more complex example next time. The concept is very important. Once you know the basics, learning advanced will be easy. So I hope you enjoyed this video. Let me know in the comment section if you have any issue. I will try to make one more video on thread. So that's it, everyone. So subscribe to the channel, click on the like button there, and do share with your friends. Bye-bye.